Like we made it. I think that this is going to be the final video, hopefully, for the quadratic section. So when we mention quadratics for the first time, in order to solve them, hey, look, I'll just dial it back. I'll dial it back here. We can see it. I think it's around here someplace. Oh, here it is. Solving quadratic equation number 3 down there. A foolproof method is using the quadratic formula, right? This works whether or not your quadratic is factorable or not. It will always work as long as you're using it correctly, right? And so that's what we want to make sure that we can do. Here, let's fast forward through all this stuff again. And we are right about, there we are. Okay, so quadratic formula, A, B, and C are real numbers. So far in your math career, that's probably all you know about are real numbers. The other kind of numbers that it's referring to are called imaginary numbers. That's the, see, real, and then you have imaginary numbers. And that comes from the stuff that's underneath the square root. What if you put your B in there, and your A in there, and your C in there, and this turned out to be a negative number? Then that turns out to be an imaginary number, square roots of a negative numbers. That's all about, that's some stuff that you'll do in Algebra 2 for sure. Okay, so we got A, B, and C real numbers. A is not 0, because if it was, then it's not quadratic. Solutions to the quadratic equation, ax squared plus bx plus c equals 0 are, and then we have the quadratic formula. Okay, so the quadratic formula looks like this. And notice that it is in compact form, 2 different answers, because quadratics, that's what we're expecting. It's negative b plus or minus the square root of b squared minus 4ac all over 2a, where the b's, the a's, and the c's, they're just coming from the numbers that you have inside of your standard form of your quadratic equation. Okay, so most math teachers, what they do is they have you sing this to Pop Goes the Weasel, and that's what these songs are that are over here. So this is almost going to be like a reaction video. I know how much you guys love those, so I'm going to tap on one of these, and we're going to see the quadratic song.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you try. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
I feel like there should be some cheering after that or something. Okay, yeah, that was embarrassing. Okay, anyway, so what I'd like for you to do is, as we've done with some of the other ones, go ahead and pull out your green sheet. Let's take a look at that guy. And it's over here. And the quadratic formula is on here. It's the one in that last box here. Foolproof method to solve a quadratic equation, and there is that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so here is an example worked out. Again, if at some point you need to refer back to it, you have a nice, neat, worked out example. In this example, we have 5x squared minus 3x minus 1 is equal to 0. It is quadratic. My a is my a is 5. Negative 3, you pull the sign with it, is my b. Negative 1, again, you pull the sign with it, is the c. And now you cram those numbers into these quadratic formula, and then you simplify where you can. So it's negative b. My b is already negative, so I need to make it positive. Plus or minus. Remember, like in that last video, we saw that happen when we're taking the square root. We have both a positive 1 and a negative 1. Square root of, it's the b squared, so negative 3 squared, which will simplify to 9 further down the road, minus 4 times my a value, which is 5, times my c value, which is a negative 1, all over 2 times a, which is there, and then we simplify it down. Does the square root of 29 simplify any? Nah, it sure doesn't. So leaving it in this form, it's a nice compact form. It's actually 2 answers. One of those answers is 3 plus the square root of 29 over 10, and the other one is 3 minus the square root of 29 over 10. And what it highlights here that I'm going to call your attention to is the fact that these are the exact irrational. You may have talked about in algebra the difference between a rational number and an irrational number. An irrational one is one whose decimals, they They don't repeat with a pattern or they don't terminate. It's actually random and they're infinitely long, like they never, ever, ever stop. And they're not just from square roots. For example, pi is another example of an irrational number, the 3.14 business that goes on and on forever, okay? And so a compact way to write a number that has an infinite number of digits is just like this. Just leave it as the square root of 29. It's all of it over 10. But sometimes we like to have an approximation, and that's where you throw it into the calculator and you put the two little squiggly marks to indicate that it is an approximate solution instead of the exact one. Okay, so let's try an example on our own, right? And that one is right here. We have 2x squared minus 7 is equal to x. It's a quadratic for sure. We can recognize them by now. We have an x squared term. And this one does have a linear term in it, so I can't use that nice advanced technique where I just isolate the x squared term. I'm going to have to make it equal to 0. Notice on the quadratic formula, whenever I'm using it, it is equal to 0, just like it is whenever I have to try to factor those things. Okay, so back over here in Notability, let's pull up this writing space here. So I need to put it in standard form. To put it in standard form, this x term, hey, I'll do this one in red, that's cool. This x term needs to come over here, and we usually put them in order. So I got to subtract it over. It's going to be 2x squared minus x, and then minus 7 is equal to 0. Okay, now, of course, you could try to factor this one. Absolutely. And you know what? Let's see what happens when we try to factor it, okay? So note that you have to use the AC method on this one because you have a leading coefficient. That's a 2. And if I multiply that 2 times the negative 7, I have a product that is a negative 14. And then the sum is always the middle one. The sum of those two terms is a negative 1. And so here's the trouble that you run into, that when we try to think of two things that multiply up to 14, we got 1 and 14. There's nothing, you can't add or subtract and get 1 from that. You also have 2 and 7. 2 and 7, I can either get, like with the signs, I can either add them up and get 9 or I can subtract and get 5. I can't get 1 from those. And then that's it, right? We have no other options, which means simply that this thing is not factorable. It's prime. And if it's prime, the only method that you have available to yourself is the quadratic formula. So if you need it, you can write down separately what your A, your B, and your C is. But, you get practice with this. You don't necessarily have to write it down. You could just go straight to the formula, plugging your numbers in as you go. What is our B value here? See, it's just negative x. Well, that implies that our B value is negative 1, and our C value is a negative 7. So let's throw everything into our quadratic formula. X is equal to a negative B. It's already negative 1, so make it a positive 1, plus or minus the square root of b squared, negative 1 squared, minus 4 times my a value, which is 2, times my c value, which is a negative 7, all over 2 times a, which is 2. Okay? And now it's just time to do some arithmetic and some simplification. 1 plus or minus the square root of. 1 squared is a 1 up there. When I square that negative, it'll be positive. Okay, and then when I multiply this, I'd have a negative 8 for those two times a negative 7 makes it a positive 56. So I have a 1 plus 56 all over 2 times 2. I got 4 on the bottom, which means I have final answer as x is equal to 1 plus or minus the square root of 57 over 4. And there you have it. Now remember that this is essentially, I'll box them, because that's what we like to do. Hey, this is my answer over here. Remember that this is essentially two different answers. One of them is with the positive square root of 57, and the other one is with the negative. And notice also that the square root that we have, square root of 57, it's not a perfect square. It's not going to be a whole number. How do I know that? Well, because when I look at my perfect squares, this is in between two big ones. So 8 squared is a 64, and a 7 squared, there's my screen not doing that thing that it didn't do before, again, is a 49, right? 56 lives in between there someplace, so the square root of 57 is someplace in between 7 and 8. It's not a whole number. All right, that's it, guys. That's it on quadratic equations. That's going to summarize basically all of our algebra review. And so you are at this point, yeah, there we are. We are at this point ready for our level 2 of Delta Math. So you want to go on Delta Math, complete those problems, and we'll call it a day.